Welcome to the new section, titled Descriptors and Context Managers. In this section, we're going to learn how to use properties, descriptors, and context managers, and what happens when a variable enters or exits a block of code. Just a note, descriptors and decorators have similar names, and it's not uncommon for people to get them mixed up. They're very different ideas, though, so keeping them straight would be good. Now, we will look at the video, Descriptors to Control Attribute Access. In this video, we're going to start off looking at the simplest and most widely used mechanism for creating a descriptor, the property decorator. We'll see how to use it to control what happens when an instance variable is accessed for reading, writing, or deleting. After that, we'll look at the underlying mechanism that the property decorator uses, and we'll see how to use it to create reusable descriptor types that can be used in more than one place at once. Once we've got the big picture, we're going to look at a few important details before we wrap up. As I mentioned, the most common application of Python's descriptor capabilities is the property decorator. A property looks like a variable to the code that accesses it, but it actually consists of 1, 2, or 3 functions that get called to fetch, store, or remove property values. Use cases for properties are a little difficult to nail down. One case happens when we've already released our software and we had a variable as part of the public interface for one of our classes. But now we've discovered that we need to do some processing when the variable is read or assigned. We could remove the variable from the public interface and create an accessor function for it. But using a property allows us to keep the interface unchanged while still allowing us to move forward with our design. A somewhat related case happens when we simply want our users to be able to interact with a value as if it were an attribute, even though we want it also to be instrumented. Representing the value as a property instead of a raw attribute can be part of our design from the beginning. We can also create read-only values by setting them up as properties that only know how to get the value, not set or delete it. Properties can be used to validate values assigned to variables by running the necessary checks when a value is assigned, and raising an exception if the value assigned is not valid. Finally, we can use properties to create alternate versions of other variables. For example, if we have a temperature stored in Celsius, we could also create a property that represented the temperature in Fahrenheit, and have its getter and setter use the Celsius variable with the appropriate conversions. Similarly, if we have a class that represents a rectangle, we could have properties that allow us to access or change its center point, even if internally the rectangle is represented as a top left corner position and its size. The key here is that the properties are providing a different view of the same data that we could access through a different variable, without actually duplicating the information. I'm not going to argue that properties should or should not be used in any of these ways, but I will say that they can be useful, so it benefits us to know about them. So fundamentally, this is all that is needed to create a property. Inside a class, we decorate a function with the property decorator, and a property is created with the same name that the function had, while the function itself becomes the property's getter. The getter is just the function that a property uses to get the value, when some other part of the program tries to read the value of the property. If this is all we did, the property would be read-only, because it would not know how to set or delete the value it represents. It's easy to add a setter to a property, though. That's what we're doing here. To assign a setter to a property, we use that property's setter decorator on another function. This decorator creates an updated version of the property that includes the setter function, and assigns the updated property to the setter function's name. Notice that our getter function and our setter function have the same name here. For that matter, so does the deleter function below. That's normal when we use the property decorators. If they had different names, if they had different names, like this, then Z would be a property that only had a getter, W would be a property that only had a getter and a setter, and Q would be a property that only had a getter and a deleter. That's because each function creates a new updated property object. Since both of the later functions are decorated with decorators provided by the Z property, each of them would get an updated version of that property, but they're two different branches of the tree. So the one with the setter has no deleter, and vice versa. We've also polluted the namespace of our class with a couple of unneeded names. On the other hand, done this way, first the Z property is created, then it's replaced with the updated property created when we assign the setter, and then that is replaced by the last update, when we assign the setter. The property decorators are really meant to be used, and our property has all of the functionality we intended. While there's quite a lot to say about properties, actually making them and using them is simple, as we can see. Let's move on. There's one big downside of properties. Each one is unique. The getter, setter, and deleter are all defined right there as part of the class that contains the property, so we can't easily factor out what they do and reuse it later. The getter, setter, and deleter are all defined right there as part of the class that contains the property, so we can't easily factor out what they do and reuse it later. Fortunately, properties are just a useful special case. The property decorators create a descriptor for us, but we can create them for ourselves. A descriptor is just a Python object that supports what's called the descriptor protocol. Fundamentally, that means it contains a method named _get__, which accepts two parameters. If we put such an object into a class and assign it to an attribute name, instances of the class will use the descriptor to control how that attribute is accessed. Here's the all-important get function, which makes instances of this class into descriptors which can be used in other classes. It has three parameters: self, instance, and owner. The second and third parameters, instance and owner, are fairly simple to understand. The instance is the object that contains the attribute we're controlling with this descriptor, and the owner is that object's class. The first parameter, self, means the same thing it always has. It's an object of the class we're defining right here. However, for a descriptor, that's a slightly complicated concept, because the object is a class attribute of the owner class. It can be tempting to store per instance state information in self, unless we take into account that the same self might be interacting with many instances of the owner class. The instance parameter might contain none if the managed attribute was accessed on the owner class instead of on one of its instances. We can do whatever we like in that case, but most of the time we're going to want to just return self when that happens, as we do here. That way, we retain a way to directly interact with the descriptor object by accessing it through the owner class. In this particular get method, we're just using the getAttr function to retrieve a different attribute on the instance and returning that as the value of the managed attribute. We're using getAttr instead of just accessing the attribute name directly, because the name of the attribute we're retrieving is not constant. It's stored in a variable. That brings us to the two initialization functions that descriptors use. One is the standard constructor, which is common to all classes, the $init function. The init function receives all of the parameters that we pass to it when we created an object of the class, and is responsible for storing or otherwise processing those values. But there's one critical piece of information that is not yet available when the init function is called: the name of the attribute we want this descriptor to control. The functions and data values that make up a class are all created before that class object itself can be created, and before they are assigned to any of the class's attributes. There's no way Python could automatically pass the attribute name to the constructor, and making our users do it manually would be redundant and a waste of time. Instead, descriptors get a second initialization function, called __set_name__. The setName function gets called after the class's initialization is complete, and the values have been assigned to attributes, and it simply informs the descriptor object of what the name of the attribute it's controlling is. Here, we're using that attribute name to create a name for a new attribute, something unique to our descriptor, where we can store data value without interfering with anything. This is a common technique. The managed attribute is part of the instance, so it often makes sense to store whatever information we need as part of that instance too, as long as we can be pretty sure it won't be overriding anything that the instance needs to operate correctly. Here, we prefix the name with a long string that is very unlikely to be used otherwise, so we're pretty safe. This function is used to assign a value to the managed attribute. Unlike get, this function will never be called with none as the instance. The instance parameter will always contain a valid instance, and the value parameter contains the value that's being assigned to the managed attribute of the instance. The set method is not required. A descriptor with no set method is still valid, but it becomes what Python calls a non-data descriptor. A non-data descriptor provides managed access to an attribute as long as no value has been assigned to that attribute. But if the value is assigned, the assigned value overrides the non-data descriptor. This allows us to create descriptors that provide a default value, but can be overridden by assigning something else to the attribute of the instance. Python's functions implement the descriptor protocol as non-data descriptors, allowing them to create bound method objects when accessed through an instance, but still be replaced by assignment on a per-instance basis if we need to. There are a few other use cases, but for the most part we're going to find data descriptors more useful. Data descriptors do have a set method, but it doesn't actually have to do anything. It can just contain the pass keyword if we want to ignore it, or it can even raise an attribute error exception if we want to make sure that nobody even tries assigning anything to the attribute it manages. Just by existing, the set method makes the descriptor into a data descriptor, which decides for itself what happens when an assignment to its managed attribute is attempted. In our case, we're running the validator function each time a value is assigned, and either storing that value or rejecting it with an attribute error depending on what the result of the validation was. The third thing a descriptor can control is what happens when the managed attribute is deleted. Here, that's simple. If the managed attribute is deleted, we delete the data storage attribute we've added to the instance and call it good. The delete function is optional, and leaving it out doesn't mean anything except that trying to delete the managed attribute will raise an attribute error. Creating our own descriptor class instead of using a property means that the descriptor class is now available for us to use and reuse easily. That pays off here, where we add all of that functionality to our class and its instances easily, without repeating ourselves. We've talked about this before, but now we can see it. The home page and news page class attributes are instances of the runtime validated class. Depending on which of them we access later, the self parameter that is passed to the descriptor's functions will either be homepage or newspage. Furthermore, homepage and newspage are part of the arbitrary thing class itself, not the objects we create from that class. Here, we're creating an instance of arbitrary thing, and then assigning values to its homepage and newspage attributes. Furthermore, homepage is managed by instances of the runtime validated class, but since the values we're assigning pass the validation, it just quietly does what we've asked. This, on the other hand, is not a valid value according to our validation function. So when we try to assign it to a managed attribute, we get an attribute error for our troubles. So, properties and descriptors give us a lot of flexibility and control when it comes to accessing attributes of class instances. Computed values and validation are just the tip of the iceberg, and I'm sure you can see other things you'd use them for. Remember reactive programming? We could do that with these tools. Or we could create local proxies for remote data, or, well, the possibilities are endless. We'll pick up in the next video with context managers, which are a different way of controlling access to variables.